Hi, this is Mr. Knowles, and this is a lesson about multiplication sketches. Basically, it's a continuation of using the area model of multiplication to solve double-digit multiplication problems. This worksheet is titled Multiplication Sketches, so that kind of explains what we're doing here. You can get this worksheet from me in class, or I believe it's available on my webpage to download, and you could then print it. So feel free to do so. Let's get started. Multiplication sketches. 1A. Carlotta has a piece of construction paper that is 12 inches by 18 inches. She needs a square that is 10 inches by 10 inches, so she makes 2 cuts in the paper. After making the cuts, Carlotta gets her 10 by 10 square and 3 other pieces. Use a multiplication equation to label the area in square inches of each piece in the picture below. Okay. So we have this picture here. I know that this 18 inches, that this is 10, and there's 8 of these here, these little dashes. And over here on the left side, I know that this 12 can be broken up into 10 because this represents the 10, this rod. And then there's 2 dashes here. That's 2. So inside, we kind of have an area problem. So inside here, this becomes a 10 times 10 problem, which is 100. Over here, this becomes 8 times 10. That's 80. Down below, this becomes 2 times 10, 20. And this lower right-hand one is 2 times 8, 16. And if we add up those 4 pieces, that will equal the total area of that rectangle. So 100, 80, 20, and 16. Add them up. 6, 11, 216. So I answered 1A. 1B, down below. I don't know if you can see that or not. Right here. Now I'm doing B. Determine the total area of the original 12 by 12 or 12 by 18 inch piece of paper. Well, I already solved that. 216. And did I solve 1A just to double check? Use a multiplication equation to label the area. I labeled the area of each piece in the picture below. Yeah, I actually used the area model of multiplication, so it's a little different than what you might be thinking, but that's what I did. So that's correctly labeled. All right, let's go on to the next one. 2A. The Woodlawn Preschool has a small playground that measures 17 meters by 14 meters. They want to divide it into different sections: a play area with equipment, a garden area, a picnic area, and a running strip. The playground is shown below. Use a multiplication equation to label the area in square meters of each piece in the picture below. Alright, so it's just like what we did before. The 17 up here can be broken up into 10, and I believe there should be 7 of these. 6, 7. And then on the side, the 14 can be broken up into 10, and this is 4. These 4 dashes equal 4. And basically, this section is 10 by 10. And what is 10 by 10? It's 100. Well, we're working in meters, so I'm going to label it meters. To the right, this section becomes 7 by 10. That's 70 meters. And then the running strip in the lower left-hand corner, it's 4 times 10, that's 40 meters. And the picnic area in the lower right-hand corner, it's 4 by 7, 4 times 7, that's 28. It's in meters. Now I'm going to add those up. 100, 70, 40, and 28. Those are my partial products. 8, 7 and 4 is 11, plus 2 is 13, 238. So down below, what is the total area of the entire 17 by 14 meter playground? 238 meters. That's my answer to part B. Alright, let's continue on. Multiplication sketches. This is on the other side of the paper. Sketch an array for each of the skeletons below and label each part with a multiplication equation to show its area. Then find the total product of each array. Alright, so I have 13 times 15, which is down below here. And they already set it up for me. There's no more grid though, so we kind of have to imagine that. I think you guys can do okay with that. The 13, this is 10, this is 3. And the 15 on the side would be represented this way, 10, and there should be 5 of these. And now I have to imagine that there's some rectangles in there. What's nice is I have these gaps here that I can see and visualize. Oh, there's a rectangle there. At the ends here, there's a rectangle there, and then this line would continue, and this line would continue. So I have 4 regions or rectangles, and all 4 of them equal the total area of the whole rectangle, which is the answer to the problem that we're doing. Alright, so let's do the first one. I think I'll use a different color. So 10 times 10 is this rectangle. That's 100. Let's go to the right. 3 times 10, that's 30. Alright, lower left-hand corner, 5 times 10, well that's 50. In the lower right-hand corner, 3 times 5, that's 15. Now I just need to add those partial products up. So I'm going to go over here, put them in a way I can add them. 5, 9, 1. So the answer to 15 times 13 is 195. I think I have time for one more. So now I'm going to do this problem, number 4. 16 times 17. And again, they set this up for us already, which is kind of nice. The 16's right here. This represents 10, and these 6 dashes represents 6. And then up above, this rod represents 10, and there should be 7 of these that represent 7. And what's going to happen is it's going to make a rectangle when I draw these across, like this and like this. Now I just have to solve the area of those four smaller rectangles. So 10 times 10, that's 100. 7 times 10, that's 70. And then the lower left-hand corner, 6 times 10, that's 60. And the lower right-hand corner, I have 6 times 7, and that is 42. Now I just need to add those up. So I have 100, I have 70, I have 60, 42. So 2, 6, and 4 are 10 plus the 7, 17, carry the 1, 272. So the answer to 16 times 17 is 272. I think that you can do the rest on your own. So try to do that. Come back to me when you can and show me how you did. If you're still in need of some help or if you have some questions, please ask me. I hope this has been helpful to you. Have a good day.